Hello, everyone. How's it? So we're here today. We're going to go through a volcanic update on, Mauna Loa and Kilauea. It's a few different things. We're going to start with Mauna Loa. Then we're going to talk about the magnitude 4.9 that happened yesterday morning early. Then we're going to talk about a little bit about the lake sample that happened at Halemaumau, at the new crater lake that's been forming over the last several months.
Yeah, and all this stinky gas.
Right, and then we'll talk, about what everybody's been smelling.
Yeah.
We've been getting plenty of people mentioning about smelling, weird things in different areas around the island. And we'll just do a general Kilauea update as well.
Yeah, sounds great. Yeah, that's what you guys are wanting to hear. So we'll try to answer you guys' questions, starting with Mauna Loa.
All right, well, let's take a look at Mauna Loa. So this is the caldera at Mauna Loa. This is Civil Air Patrol did this flight on October 20th, and they took these photos. You want to?
Yeah, sure. This is it's like Dan described. It's a summit of Mauna Loa, Makua Ve'o. That's the other name of it. We're looking kind of from the southwest and northeast. It's across a little pit crater in the foreground of the photograph right there, and looking down the long line, a fissure line. Actually, we're looking from east to west. Yeah, now that I look at it again, from northeast to southwest. There's pit craters on both sides, and a long fissure line with a couple lava spatter hills in the middle, kind of towards the far end of the photograph. You can give me a little circle back over here and show some of those cinder cones that came out of the middle of those fissure lines in the kind of northwest side of Mauna Loa summit, that are all eruptions fairly recent in the last few hundred years, kind of filling the whole caldera era of Mauna Loa. So yes, really, we're looking down a long way of it, and the skinny axis is kind of left to right. So it looks massive, but if we actually could see it, it's kind of long, like a big kidney, right? It's much longer towards the back of the photograph than it is left and right.
Right. So we're talking about Mauna Loa first and foremost because it's still at the main priority on the island for us right now, with including USGS. They have it at yellow, where everything else is at a green warning level. It remains on the watch list, mainly because the elevated seismic activity that's been happening in the past several months, and it's just been remaining high. But we want to kind of discuss that a little more now.
Yeah. One thing I could say is that what this photograph really shows is that all the area in the caldera has been filled by recent eruptions, and most eruptions in Mauna Loa begin with summit eruptions at the caldera, as we've discussed before. And so when we look at Mauna Loa's pattern of activity, we're going to kind of keep that in mind. Right. As far as what we might expect actually next. So here's our earthquake map, showing the last month of earthquakes over at the top of Mauna Loa. This is from the USGS Mauna Loa monitoring website, right? And what we're interested to look at first is the actual earthquake counts, right? So we're going to scroll down a little bit on that page right there, and we'll look at the numbers of earthquakes per day as they've been occurring in this plot over the last month. And what we can see is that we've had a rise in the last week or so, or a couple of high points. Apart from that, the plot is kind of not that unusual, right? But there definitely has been a little bit of pickup recently, and that's something that we see just in our earthquake numbers. These are all shallow earthquakes happening up near the surface, above sea level, within the actual mass, the mountain of Mauna Loa.
Right.
And that's one thing that's a cause for extra vigilance.
I think we're okay.
Yeah. Can you guys still hear us?
OBS crashed. Okay, I think we're back.
All right. So yeah, sorry about that, you guys. I think we're back.
Are we back? All right. Chat, are we back? Are we good? I'm taking that as a yes. Your no response is affirmation. All right, so one thing that's interesting here, we have definitely a little bit of a peak. Well, we can show this a little more when we look at the past year, right? And this kind of shows, past 5 years actually shows it a little better. 5 years. All right, so in here we can see the 2018 eruption. Where that'd be right in here, and the lack, how activity, earthquake activity at Mauna Loa seemingly, dissipated considerably from what it was before. So did deformation at this point. So the alert level was lowered to green, and then this little guy happened this month.
Right, October.
October happened.
2018,
1 year ago. And then we had a few more months of elevated activity, and this is when the yellow actually happened. So right in here is yellow has been turned on by USGS because of the elevated seismic activity, right?
Yeah. So yeah, at the end there, you can kind of see, after they raised it to yellow, the activity went up. It went down a little bit, and now it's popped back up again.
And then we got this little guy, and this little guy is pretty high up there. That's the thing, is that's not just a little guy. Actually, that's a considerable number of earthquakes. We've seen this before. Nothing happened here.
Right.
Like there was no eruption when this happened, but we have another one of those 1 year later.
Right. Yeah. So I mean, one of the things that we look at is absolutely the live numbers of earthquakes, but we're also interested in looking at other aspects of the pattern of where these earthquakes are occurring on the map, and whether there's changes in GPS or tilt that go along with that, as opposed to just a heightened activity of earthquakes in one particular area. Magma could be moving under there, but is it actually building towards something more imminent, or is it kind of part of this longer term building trend that we've been talking about and we're still in for many, many months? Is there a reason to kind of shift our alert level yet? Is I suppose a real question for our viewers. And it's just not clear that there's anything beyond this number of earthquakes gone up yet, right? We don't have a view of the INSAR data. And what we can see of the tilt in GPS we'll look at shortly, not quite yet, doesn't show that anything changing up there, right? The first thing we're going to look at is actually the changes we can see are the patterns of where these earthquakes are occurring, because over the last 6 weeks or so, it's been much different than the 6 weeks that were before that as far as the pattern of earthquakes at the summit. And different as well from the kind of long-term periods of earthquakes we see at the summit preceding eruptions, right? So we can let's
look at some different times.
Yeah.
So these are periods where there were not eruptions. It's kind of standard earthquake activity from Mauna Loa. You have these two predominant areas that have historically just been the high areas for seismic activity, especially in the last decade.
Right. So one of these areas just kind of west of the summit,
right,
and one southwest of the summit. Right. Yeah. Exactly. Looks like we have a little Halloween ghost face.
Right. So yeah, right off of the summit, you can see up until recently, up until October, that has been the case. You can see in 2013 to 17 during the yellow, the elevated activity then, which had a bunch of deformation associated with it as well.
Right.
You can see the similar type pattern. It likes these two spots, and this is a historical pattern. You go to 84, 75, you look at the earthquakes, you find the same type of pattern.
Right. So what we're really going to point out a difference is look at the difference into the summit itself. Right. So look at how few earthquakes are in that summit caldera region. Right. There are definitely some in there, but just not covering the background like it is just to the south of there and to the west of there.
Right.
So,
all right. With that in mind, we look at what it is now. So let's look at the past month, Mauna Loa.
Right.
Let's look at this now.
You can see, there's a big kind of a blob within the caldera itself that's kind of merging with that blob to the south right there, right? It's kind of, if anything, that blob to the south seems to have shifted and is kind of blurring its way to the northeast into the area of the caldera. That one to the northwest is kind of still there.
Right.
But, the one that's maybe draw a box, around the one that's new, right? So that inside of the squares area, that's less common to have that many earthquakes recently. And so that's the one thing we've noticed in a change over the last 6 weeks or so. So like we said, that there's actually no corresponding change on tilt. The tilt meters are looking flat. The GPS, we can maybe look at the GPS extension line across the summit. It's still climbing as it was before. It possibly could be climbing a little bit steeper, but we'll have to probably wait some more time to see how that actually pans out, right? So yeah, right here we have the USGS page, Mauna Loa. Look for the last 5 years. You can kind of see that the era, that's kind of averaging since the end of 2018. We could maybe make a distinction between 2018 and maybe a month or so, a month and a half ago. And since then, it's been steeper, right? And this is easier to see if you kind of look at the zoomed out view. So if you kind of back out of this, onto their page again, and look at that plot just below there. Or is that the one we're looking at? Yeah.
Yeah.
That was the right one. I'm sorry, guys. Yeah. So that's the one that really shows right there how it looks steeper at the end there. It's not as clear as the one right above it, is what I was trying to get at, right? If we look at the zoomed in view for the last year or so, it's not quite as clear that the segment on the right is actually quite a bit steeper, but that's the section we're looking at blown up right there.
Something like that, potentially.
Yeah, exactly. So it's still to be seen, whether that's a real trend or not. We're always very careful with these things, but those are the changes that we're looking at, keeping our eyes on today on Mauna Loa.
Right, and you can see here, we're going to look at just the past. So this was September.
This was August 15th.
August 15th.
Until the end of September. So it's the 6 weeks ending in September, at the end of September.
And you can see again, we're going to draw it again, the two spots. Boom, boom.
Yeah, and
that's the caldera right there.
And you can kind of see, we actually have, this search result shows a raw number of earthquakes in this area, right? And for this earlier period, it's showing 69 earthquakes of all sizes without any kind of differentiation to the size of them.
And now let's look at the last 6 weeks?
The 6 weeks following, which is the 6 weeks since then until now.
So we're going to draw it again. Boom, boom, caldera.
Yeah, and right in there you guys can see 84 earthquakes shown on a map area, and most of those other 15 or so are actually found in that caldera. So it's not a whole lot. It's not like a big swarm. It's not something that we're worried about as far as it actually building towards an eruption.
It's just one of those things that's worth pointing out.
Magma is not about to break the surface, but it is probably moving within the summit caldera, summit magma chamber underneath the summit caldera on Mauna Loa right now. And so it is still a time to be getting prepared, being vigilant. We're going to there's no reason to panic or anything yet, but we've been saying for a while that we think Mauna Loa is in a building phase, and it's a matter of time before it erupts, and not a matter of if it's going to erupt, but when.
Right. Mauna Loa, one thing that has on our side with Mauna Loa is that historically it erupts here first, right at the summit.
That's right.
Right in that close proximity. It will be bright. It will be when it goes night. You will see it from Hilo to Kona. There will be no secret that thing is going.
Right.
It's not going to sneak up and pop out of the side, near homes right away.
Right.
This thing has a even the beginning parts of an eruption isn't dangerous potentially, like for people.
That's right.
Air might get stinking Kona again.
Right.
Something along those lines.
Yeah, and that's once it actually happens, because we do expect even at elevated earthquake rates of, let's call it 40 a day. I think it might have been the biggest number we actually saw within the last week. We're still not a number of hundreds or thousands per day would signify magma moving through the ground towards the surface, right? So we're not really anywhere near that kind of level of panic yet. So we'll see more signals before that happens. We're still waiting for the typical earthquake on a flank of Mauna Loa that usually signifies the flank is adjusting enough for the magma to be rising through the summit.
Right.
So that we're waiting for that as well. We're waiting for gas emissions to go up.
There's all kinds of
There's a lot of things that we're looking at. We have heard that the NSAR is similar now as to other eras of inflation at Mauna Loa. So there's nothing kind of unusual there either.
Right.
And we're just kind of waiting to see when it kind of shifts into the next gear. And this is kind of one of these points, these pit marks that we could say is one of the points towards increased activity, but it's not actually quite there yet. Yeah.
Right.
So we'll keep an eye on it, you guys, and I don't have anything else myself about Mauna Loa. Unless you do.
Nope. Let's talk now about some earthquakes. Continuing on, so we're coming down off of Mauna Loa. You can see the earthquakes we were just talking about up here in that giant area.
Right.
Just cover that up because we're moving on. So it's still Pahala quakes, still happening. Right. Not much change there.
So this is the last month, right? This is the last month of earthquakes on the USGS website that we're just pulling up and kind of streamlining for you guys, so you guys don't have to you've seen us navigate here before.
Right. So now we have one other quake that happened yesterday. Let's talk about a little bit up north. This bad boy. Let's go.
Yeah. So this was an earthquake that happened in the morning yesterday. And it was about 6:30 in the morning. It woke me up, got me out of bed, to go and see what was going on. There was an earthquake that was felt a lot of places across the island. We'll show you guys.
Right. It was felt widely. You can see this is a
shake map.
A shake map, and you can see these are all felt reports. So these are, this particular area, this 1 kilometer square had 4 responses from people that felt it. And the color denotes the intensity at which they felt it as reported. And you can see how many people around the island felt this thing.
Yeah, so thank you guys for all submitting felt reports. You guys can see the efforts of the map of your efforts right here, right? And one kind of at a glance, most people are showing kind of that bluish, grayish color. A couple of yellows, that's who felt it the most intensely, right? So in a bigger earthquake, you'd see more yellows and possibly some reds closer to the actual earthquake epicenter.
Right.
And kind of less going away from there. So, but what you really can see is that the squares are all over, right? Basically goes around the whole island like a lei. All the people who felt this earthquake, and I'm not sure beyond that, right? But because it happened so deep, this earthquake was 20 miles underground, underneath the east flank of Mauna Kea. And because of that depth, it's most likely that it's a settling event of the mountain, the weight of the mountain.
Right.
Right. That, it's kind of cooling down after having moved off of the hot spot, and it's kind of not erupting anymore and contracting, long-term cooling. So,
these are kind of normal for the area, the depth. They kind of happen randomly, even offshore.
Yeah.
These quakes have happened, and we've had larger magnitudes as well for these types of quakes.
They can be destructive for sure, right? But they're not predictable in any way, and are not tied to any of the volcanic activity. And one thing that the USGS has shown concern in, because they put out a press release, is that they actually stated that the earthquake caused no changes on Mauna Loa or Kilauea, right? So something that people have asked before in the past is, can earthquakes affect eruptions or plumbing or that kind of thing? Usually, it's if it's ready to go, the earthquake could set it off, but it's not the thing that's going to cause eruption to go most of the time itself, right? It's part of a larger pattern,
right, that
you see.
All right, so that was a quick little thing, 4.9. You can see the shake intensity, and really no damage reported that I've heard of. No, not really. No, it was more just kind of like let's check back in and see what's going on kind of event, right, as far as I can tell from my friends. Can we go back to the map of all the earthquakes on the island? Just so we can point out a little bit of the other populations, because we're not going to focus too much on earthquakes and the data quite yet, but I want to kind of just point out that we have stuff happening in the south flank as well. Dane pointed out Pahala and the summit, so this map kind of shows the Mauna Kea event we just talked about, the Mauna Loa events, and we'll come back to this a little later. But what people are also talking about, besides the earthquake that they all felt a couple of days ago, woke them up in the morning, is been going on for a lot longer than that one day. It's been going on for weeks. For weeks we've been hearing people reporting extra stink down in Puna, Right, and not just Puna, around too, Hilo, HPP, Fern Forest, just
Volcanic,
Noni Farms near the recent eruption, in areas that wouldn't make a tremendous amount of sense. They're not the predominant directions that you would expect gases from the volcanic vents to get blown.
Right. And at the same time, we've been, still hearing USGS reports that SO2 amounts haven't gone up, that there is no indication of new magma coming into the lowest East Rift Zone, let's call it, right? We'll maybe get back to that a little bit later. But what's been most useful as far as addressing this, because we've been talking for a while, the weather's changing, we're going through our winter months, we have more slack winds, we have more Kona winds. My standard answer is that usually when all that gas coming out of the volcano gets blown towards your house, it suddenly seems like a huge amount, because even at 20 or 40 tons a day, that's a huge amount to be blowing over your house at SO2, right? So most of the time it's not blowing over your house, it's blowing over the park, blowing out to sea, and that's fine. We've talked about how H2S is coming out now is extra stinky. It doesn't take nearly as much of it for people to actually smell it and detect it. So any of these seasonal changes in the wind, daily changes in the wind, can be things that bring the gas to where people are actually smelling them.
And let's just show that real quick. The daily changes in the wind. So this is current wind, basically the windy app. We're showing current wind right here, and you can see the predominant directions. Eruption site would be here-ish.
Right.
or wherever in here. Kilauea summit would be here-ish.
Yeah.
And you'd have winds. You can see which way they're kind of swirling, but you have these predominant patterns. But you can see how they change at night. So we'll go to 4 a.m. We get rid of those little dots. And you can see how now what would be blowing southwest originally is now blowing north and can catch different people. And this H2S, especially when it's muggy out, when the humidity's high, it can stick close to that ground real well.
That's right.
And get smelt, in a completely different thing. We're in Leilani Estates right now, and I can tell you like exactly what way the wind's coming out of just based upon the smell.
Yeah,
like,
absolutely.
I'm smelling it right now. It has to be in this direction.
Yeah, so down around Leilani, in Lower Puna, there is still quite a lot of sting happening, and you can see that these winds are blowing around. But also on this map, you can see that something happening around Volcano Village in the middle of the night. Like that caldera is like a big cauldron. All those winds are actually blowing, you can see, to the east and northeast, right? So overnight, all the gas that bubbles out of the main producing gas source of the volcano is the summit can actually flow downhill with those currents, right? Actually, on the map, it's going more that way. But that's why you might smell, especially in the morning when you wake up in the early morning after several hours of the wind carrying the stuff from the top of the volcano all the way down towards Kilauea and HPP and lower parts of the island, right? So that's kind of the first default answer, right? That we usually give, and that we have to investigate further beyond that to tell if there's really any changes beyond the winds actually shifting.
Right.
What I thought was really cool was the mentioned in this week's Volcano Watch by the USGS is that there's a new website up, this air quality data put out by the Department of Health in the state, right? And has all kinds of information on these different monitoring sites across the islands here. And we're going to focus in on Puna, for example, right? But so what you can do is you can click on the actual station, and the first thing you get popped up is like a summary, particulate summary, but you can click on and go to station info. And if you watch the mouse here, you click on the graphing, and you can then look at the tabs. Now we're looking at H2S and Leilani, and by default it's showing the last day. SO2 in the next tab, where you can show them both on the same plot. But this is a little funky because it tries to plot them both at the same scale, and it does not change the number, so you can kind of see it looks like two flat lines in this image, and it's not that useful to us quite yet. So you're kind of better off clicking them separately and flipping back and forth, on how to look at this data, right? So so the data in Leilani has been collecting since September, actually.
Right.
And Leilani station is measuring H2S and SO2. I mean, you guys can look at this website a little later. The links are up around, or kind of floating around the websites now, right? So you guys can check that out.
Right, we can show some. This is a custom graph, and this is just showing again. Since September, since this data station has been installed, kind of the data that it's been accumulating. And we can see this blue line, which represents H2S in Leilani. You can see this slow little creep up in what it's been detecting. Not much, pretty small, really small.
Yeah.
When we were during the eruption, for the scale, let's just define this real quick. 0.02 ppm. During the eruption, it was around 1.5 to 2 ppm.
Right.
So 100 times less than during the eruption, but it's still there. It's stinky. People can smell it. I suspect that there's a certain amount of people that have basically a low tolerance, low tolerance. They're very susceptible to being able to smell this thing and even have it impact them in some way somehow.
Right. Like a sensitivity.
Yeah,
like
very high sensitivity.
A biological sensitivity.
A biological sensitivity to this particular gas, which has been naturally occurring.
Right.
And now we didn't, before the eruption, there were no H2S vents that you would go up to and be able to pull an H2S number on and be below detectable limits.
Right.
Now that's not the case. There are vents that do have H2S at them, and this is kind of what this is showing. This particular monitoring station, this Leilani Estates monitoring station, is installed at the community association, which is not downwind, or what I would call downwind of the volcanic vents, but it's close. And it would catch these, when the winds change, it would catch the the wind and the
Right.
gas and get these types of measurements.
Right. So, yeah, so you guys can see, like, on a plot, there's some little bumps and little spikes, and that could be like the variations of the wind, the day to day. But what's really interesting is that we have the blue line is showing a gradual rise, and it's true. It's very small numbers, but it's still showing an increase. From so let's call it 0.01 to it's been about 0.04 recently up here around Leilani. And if that's actually true, that means that there's more interaction with water and the magma or the magmatic remnants underground, and that's the same as been happening the whole
for the past year,
few months since the eruption ended. It's just happening more, and it's happening by the looks of this graph at a fairly steadily climbing rate, right? So maybe that as the ground is cooling, the water is kind of getting a little closer,
getting deeper.
There's more of it flowing with more force. It's reaching areas where we're producing gradually, little by little, and a very measurable. Looking at that blue line right there. Kind of way, a steady climb in the amount of H2S that we actually have, right? In comparison, that red line is a SO2, right? So SO2 is showing essentially flat, apart from one spike that we're not quite sure what it was.
We're not going to talk about the spike.
It's very temporary. Yeah, I just highlighted it, and we're not talking about the thing we're circled.
Don't talk about that thing. We don't want to talk about that one. But yeah, there's this gradual increase, but SO2 is really low. But let's just look at what it was like during the eruption.
Well, the point is that we don't see this is caused by new magma, right? If there was new magma, we would see SO2 coming into that. And for comparison, high SO2 numbers. This is a station that we've pulled up.
Pahala.
10 years of data from Pahala, right?
So we have Pu'o'o, still Pu'o'o, still Pu'o'o. Going there.
And a Summit Lava Lake as well, right?
Yeah.
The Summit Lava Lake is
I went a little too far.
Producing the gas that's blowing to Pahala. A lot of it's coming from that Summit Lava Lake once it opens up in 2008, which is all in the range of this plot.
Right. So that's basically just close enough Pu'o'o, and then we continue on.
Right. So, yeah, and then during the eruption itself, during the Lower East Rift Zone eruption in 2018, and some collapse that accompanied it, you actually can see, during the collapse, the days and moments after collapse, there was a spike in SO2 that wafts across Pahala, right, that you actually can see. And that's what each one of these little bars going up, each one of those is a spike of the wind blowing across from the summit to Pahala. And then since then, the pink line right there, that's the levels of SO2 coming out of the summit.
Post-eruption, the record-setting, non-existent gases, the clean air that USGS has been talking about, and many people on Kona side have been talking about, this is it.
Yeah, and clean by relative standards, right? Because people are still smelling it. Some days it's really intense, and you're like, oh, I don't know what you guys are talking about, just, less intense gas because it smells really intense right now, and, we get that. That's the case, because still... It's 20 to 40 tons a day of stinky gas. Like that's still, I haven't looked at the EPA regulations for H2S in particular, right? And the SO2 ones, but that's probably above an industrial regulation just naturally. And you don't have a choice of where it's going. You can't go and find the volcano. Don't put out any more gas and blow it across my house. But that's just how it is, So relatively speaking, how much is coming out compared to whether it's going to erupt or not is what we're really concerned with. We understand that everyone is smelling and, concerned by the extra stink, but it's at the moment no cause for alarm. It just seems like a pattern of water moving in and producing more gas
and weather.
Wind is shifting. Yeah, more gas may well be being produced, as we saw in our last plot, right? And then the wind is helping us spread it around even more. But the bottom line is none of that means new magma. New magma is something we can maybe extrapolate, talk about through other techniques that are not what we're seeing right here.
Now, USGS has added some of their own gas monitoring to their monitoring section.
Let's show people how to get here. If we can. Right. So this is it's a little bit hidden on the HVO website, but if you go to the main website and you go to Kilauea,
so monitoring. We're at the main website, right? We're gonna go Kilauea.
Are you going to the whole main USGS website?
Yeah, I'm doing the whole thing.
All right.
The whole thing. Then we're going to monitoring.
And then over on the left, you can click on, there's different lengths of time, right? If you go for past week, you won't see this. If you go on past month, at the bottom, you will see this little hidden section down there that says gas data. And this may be something that they're kind of deploying in concert with the DOH new website that went up, and maybe that's part of what they're experimenting on our site, and we're not sure how things will stabilize there, but what you guys can see is that there's a lot of up and down variation. You can imagine the wind. These are all 3 plots of SO2, right? And basically what they basically show is there are some spikes as the wind changes, but the bottom baseline is basically flat.
Right. And the scale is really small as well in terms of ppm.
Right. Very important.
When we were talking about during the eruption, like 1 ppm was uncomfortable for people. 2 ppm was like starting to get back of the throat,
right,
scratchy and that kind of stuff. If you get to 5, you're just like, all right, gone. You need out.
Right.
Like there's no, it's uncomfortable. No, it's just bad.
Right.
But this is the scale. We're at 0.1 scale or 0.02 scales. Yeah. So very small amounts still.
So yeah, if you actually, this is one of 2 gas plot pages. If you actually go back to the past year on this site as well, there's one more plot that's hidden in there. And so we'll show you guys that right now. Well, that's week. We want year. And
it didn't count anyways. So.
All right. So there at the very bottom, one more little plot of gas data right there. And that's now showing a year-long plot, right, with kind of average data points that are put in. So you guys can see that, the full range of the plot is up to 100 tons a day at the very top. Most of the numbers are varying between around 20 and around 60 tons a day, with maybe one above and one below that. But that's kind of been a range of it, right? So that's fairly low compared to there were eras before where we had the open lava lake putting out, as much as 2,000 tons a day.
Right.
Before there was lava lake and gas was kind of percolating through a bunch of solid rock, which maybe is more equivalent to now. 200 tons a day, was coming out of the summit, while 4,000 was coming out of Pu'o'o at the time. So most of it was actually getting siphoned to Pu'o'o, while it was kind of just leaking out of the summit. So you might say, okay, well, maybe, the USGS has actually said, oh, maybe it's close to 200 actually. We're not really quite sure. So that's really hard to say because we don't have a Pu'o'o 4,000 tons a day system going on anymore. So it's a whole new game. We don't know exactly what's going on. We'll talk about what might be influencing the gas here shortly. But just want to point out to you guys that there is this other page now that shows gas data, going back for the whole year and kind of spotty samples. So next thing on the USGS webpage that's actually been going through a lot of updates this week is they have new webcams put up, right? They've been up for a little while already.
Right.
We've have been pointing them out already, but it's made the news a little bit more in this past week, so we thought to mention it one more time and show you guys this one kind of wide angle summit camera that's showing a view down into the collapse pit and the new pond that we have at the bottom of the pit down there, right? So it's nice that USGS now has these automatic one-day time lapses, right? So you can kind of see over the course of the day what we've been talking about, all that gas, at the summit. There it is, kind of leaking out. You can kind of see how it's staining the walls where the vents are coming through the crater rubble right through there. So the gas is coming up very near to that water, right? And the water is the other thing that's made the news recently, and that's probably the next thing we want to talk about, right? Is how that water actually interacts with the gas, perhaps, because finally the USGS was able to send a drone in there.
Yeah.
And
they were so kind to share some footage we have queued up now. We'll go ahead and just play that for you.
All right, so footage of the drone.
Oh wait, that's not the right footage.
Oh.
It's close. Oh, there it is. That's the footage. Yeah. These aren't similar at all, actually. These are completely different strategies, and they're doing completely different things. But yes, we have just water samples.
Yeah, so the USGS finally got the permission to fly their hexacopter down in there and have a long rope, and you guys can see this plastic receptacle at the bottom of this rope, right? They have this professionally thought out colored ribbon system.
Right, this is what shows excellence. This is what
yeah, that's above and beyond right there, right? That's a lot of,
we grab them and go.
Great planning, yeah, and they scoop it in. They kind of let it sit in there for several seconds before they scoop it up and out, right? And they actually, you guys can see the steam blown by coming off the surface of that hot pond, right? As they lift that water bottle out of there and fly out over 1,000, over 1,500 feet out of that big hole in the ground to back to where they can actually drop off the water.
It's a huge ways down.
Yeah.
It's a huge ways down. And then we also had a little bit of a thermal video that they showed as well of the same operation.
Yeah, the camera was filming visual and thermal at the same time, and taking other kinds of samples. And what you guys can see here is mostly the steam bubbling off the surface of the lake. So it looks like the whole lake looks almost like a lava lake from Old Hale Mau, right? Was one of my first thoughts. But it's really the steam rolling and bubbling off the surface of that. And when this thing hits the water, you'll see that the water has a whole different pattern. There it is. There's a surface. You actually can kind of see some of the stuff on the bottom through the water right there. Up there's the surface of the water. And look at how we disturb the whether it's sediment or dissolved minerals or temperature equilibrium within there, because we have a cold water bottle stuck into this hot thing, right? It's suddenly going to start absorbing that heat, and it's hard to say exactly what we're seeing there, but we're seeing some interaction of that water bottle dragging through and now getting pulled out, right? And then now we have a little upwelling of steam right where we pull the water bottle out of there. So that's really fascinating and cool. And as it flies higher out through the clouds, then you kind of see the darker shadows go across there. So that really, really cool stuff. And they basically dropped us onto a chem lab up at the rim, and did analyses. And
let's pull that up real quick. Multimedia.
I'll let you pull it up. I'll kind of keep talking about it. And there's our chem lab right there, right? And you actually have an infrared picture showing how hot that water was, right? So they're still saying about 70 degrees C or so. So, and they're doing analyses right there on a spot to
It's best to get the pH that way. Just do quick, easy, boom.
Right.
Grab them.
It's not changing. You're not giving it time to really change.
Right. And this is just, of the operation, them dropping the drone in.
Yeah, there it is, yeah.
You can see the shaky cam. This was actually the cam that was used to film Cloverfield.
Yeah, you can imagine this thing's probably zoomed way in. And the person's trying to move it very, very little. And, even on a tripod, it might be kind of jerky coming down like that, right? If you don't have a fancy head.
Yeah. It's a good operation. The drone did not crash. That's a win.
Yeah, no, it was awesome, right? I mean, it pretty much went off as far as I could tell without a hitch.
Right.
Right, so that was pretty amazing there, yeah. And so, they did mention, the measured pH to put at put us back in that camera.
It was 4.2.
4.2, yeah. 4.2 pH. They talked about how there's high concentrations of dissolved sulfur and magnesium in there, right? And that's got to do with the fact that the sulfur gas bubbling through that water table through there, and the rocks themselves, the basalt lava rocks that we have, are iron and magnesium rich. So you have sources of those right there to be dissolved by that essentially sulfuric acid, solution. Yeah, that's kind of percolating the ground through there. They talked about how much sulfur is in there, 53,000 milligrams per liter, a huge amount. 75% of the total dissolved solids are sulfur in there, so mostly it's sulfate in that lake.
Right.
And they're still doing some work to figure out how much gas is coming through there and how much of it might be getting absorbed by the water. Right. One thing they mentioned, kind of ad hoc is like, well, it used to be up to 200 tons a day in the past, possibly. So maybe it's actually that instead of the 40 to 60 we've been measuring, because we know for sure we're losing some into that water. Right.
There's some getting absorbed in there. We know that the Keller well, it has a long history of getting samples, and its pH is very much near 7.
That's right.
It's very much near 7. So this 4.6 or 4.2 pH that was taken, or it's actually not as acidic as most things. It's like a tomato soup basically at that point. Exactly. It's not that acidic really.
Yeah, it wouldn't dissolve your hand or anything.
Right. It's not like that, but it's absorbing this sulfur locally.
That's right.
It's not the entire water table that has a pH like this. No, this is happening after. Yeah. It's whatever it is local, basically.
Yeah, it's where that water table is intersected by the cracks bringing up gas from the magma, which is way below that, right? So the magma is way down there in that deeper chamber, and it seems possibly, to likely in at least somewhat in a shallow chamber, but not nearly in as amounts that it was before the collapse last year. But probably still some in there because of the repeated mentions of inflation through NSR that the USGS keeps citing at the summit. So it's still coming through there. And the gas is bubbling out of that through the cracks, and the gas is going through the water, and that's what's causing it just around those cracks to be that 4.2 pH. And because we see the gas right next to the lake, the gas vents right above it, even in this wide view right here, then it makes a lot of sense that we kind of see that pH there. In fact, I kind of heard people say, "Oh, I'm kind of shocked it's not lower." Right? What was your first reaction when you?
I was thinking it was gonna be. I was thinking like 3.5. It was gonna be like not. Right. I was expecting it to be a little more acidic than it was.
Right. Yeah. That's I think I probably had a similar reaction. I've heard that from other people as well, and I think that it all depends on how much water we imagine being down there, right? Because
right.
A pH is like it's a concentration, right? So depending on how much water is being affected by this interaction of gas, you could have quite a lot of gas dissolved in it and have it still be at 4.2 pH if you have a lot of water, right?
Right. It's all about how much water is there
relative to how much gas.
Right. When we don't know that, we know how much. You can do the calculations to figure out visibly how much water is above ground here, but what about the water below the surface of this the crater that existed that a few months ago was empty?
Right.
We can't say that the water just stops there like a pool.
Yeah. Right? Where are all the gas vents underground? Which of those cracks is the gas coming up, and where is it intersecting the water table, and how many places is that happening? Is an impossible question for us to answer right now.
Right.
So we'll kind of just keep our ears tuned to the USGS and eagerly await any kind of further information on the sampling of the lava lake or the water pond. When we call it the lava lake, like old habits die hard.
So we've gone through Mauna Loa and the elevated earthquake activity recently. We've gone through the new gas monitoring out there. We've gone through the magnitude 4.9 that happened yesterday morning. Right. Well, now let's just wrap up with a quick little Kilauea update after talking about this, the lake, which is still, the lake to wrap up, still rising. Still not rising. Even close to what we would expect equilibrium to reach.
Yeah, many more months still.
Many more months.
Yeah, we hope that we'll have a chance to go back and I'm sure they do as well, sample this thing again, see if it changes, right? If we see the pH go down and gas emissions go up, then that's
saturated or something along those lines.
Right, then we know that that's kind of our new signal, right? We almost have an extra path of monitoring the volcano now because we have this pond up there, right? It's almost like a big level as well to tell us if big bubble level. It tells us which way the ground is swelling relative to it.
So what we have here is ground tilt, which if you've watched our things before, you would be familiar with, and measures, changes, very subtle changes in the angles of the ground, the slope. It's called tilt. Very, 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 like 1 microradiant is a 1 kilometer board with a dime pressed under it. That's the amount of angle change that 1 microradiant, means. So we're talking very subtle things here, and we're looking at Kilauea Summit here.
Right. So this is on the Hawaii Tracker page, and you guys can see that at the summit right here at SMC Station Summer Camp, there's 2 lines, but they're both the summit components. And what you're seeing is the blue line is the one that's showing the more interesting thing to see is all those deflation events that Dana's highlighting, right? How many deflation inflation events we've had in the last month? 1, 2, 3, 4, 5, 6, 7, 8, 9,
maybe
10, maybe a dozen-ish, right?
Yeah.
And that's not counting all those little ones kind of embedded one top of the other within there. So it's been going a lot. That's basically been in the last month, what's normal. Not every month is like this. Some months we've gone by with only 1 or 2 DIs, but this past month we've had about a dozen or so. So that's really interesting.
And as we pointed out before, the DI events, periods with high DI activity, these deflation-inflation cycle activity, are generally associated with non-eruptive periods. So it's not saying they won't erupt or anything like that. It's just when we see a bunch of DIs happening in this situation, it's...
Let me correct that a little bit, right? Because what it is it's not showing. This doesn't happen before changes to the eruption. Like there have been periods of Pu'o'o where we had a lot of deflation and inflation events also, but it was all stable. And we had periods of times when we had none, but it was also stable. But when
changes in activity.
But when it's going to change from having a lot of activity to no activity, or no activity to a lot of activity, then you expect to have fewer deflation inflations, right? So, and this is just based on analysis of Pu'o'o data, which is all we have because we've only had 2 meters so long. We've only had this record of activity for so long. So all we have to go on is a Pu'o'o era activity, deflation inflation events there. And so it kind of is offered in the context of there was eruption happening, but things didn't change within eruption until these deflation events stopped happening, or if it happened very, very infrequently, like one every few months or so.
Right.
So the fact that we see this kind of, the point Dane's trying to make is a totally valid point. What we're basically saying is that we don't expect any change at the summit magmatically now, because we're seeing a pattern that usually we see it when nothing is changing at the summit.
Right. Pretty much, yep. All right, so we have that. Now,
the other thing to look at as far as that goes is the rift zone plot, and we don't actually have it for the last couple of days because Pool went offline.
Right.
But maybe we can go to the USGS site and see the 1 month long pool going back, yeah. Or maybe
and I'd assume this little. We didn't really look at this, but I assume this little bump is the 4.9.
Yeah, right there, right after 6 o'clock. Yeah, exactly.
Right after 6 o'clock, it just made a little boop on the tilts. Can be felt.
Yeah, so
we're on GPS.
Yeah, no, or just go down to if we can get to a longer plot of Pool, for example, so we can kind of come, like for example, right there, right. So you can see that we still have what looks like daily cycles, right? This kind of sawtooth pattern is too regular, right? If you look at like the green, for example, it's a too regular pattern. For it to be regular deflation inflations, that's like a daily cycle, probably the sun hitting it, warming up, and or something along those lines, something weather related in that, temperature related in that regard. So that's on both. These are two components of Pool. It's on a blue line as well. But what we're looking at is a bigger term changes within a blue line. That's what we're more curious in, right? So we see that there is change happening on that blue line, but it doesn't seem to relate to the inflation events we see at the summit.
Right. And we've talked about how the inflation events at the summit we've seen the shadow of them at Pu'o'o on the tilt.
That's
and
right.
In this case, with these series of inflations, it's just not the case. And yes, it's offline right now, but it was much more pronounced before when we were able to say, when we were talking about it. Now, in this type of situation, it's just kind of doing its own thing.
Yeah, it's fascinating, right? And you kind of see that the change kind of happens sometime in the first half of October, right? Kind of by the 17th is when that plot actually takes off heading up, but something changed before that, right? So that now there's a separate something happening at Pool that maybe we're not seeing at the summit, right? Maybe the connection has changed in some way, right, as a result of something that happened recently, which we'll get to as well. So that's something to keep in mind, but maybe we can move on now to looking at the GPS, right? And here we are on a Hawaii tracker page. Let's do the summit plot first. So here at tracker page, the first week plots we'll skip over. We'll look at these top two plots that are the Uekahuna vertical and Pool crater distance. These both are plots of two stations getting closer or farther apart. The top one's across the summit. And you guys can see that, in this plot going back a year. So it's since in the last year's eruption that the summit has actually been spreading apart. We talked about how we had like a shallower part of spreading that might have been possibly just the south flank moving. And then since early 2019, it's been steeper, possibly an addition of a magma component inflating underneath the summit. Which has been referenced by USGS and INSAR as well, right? So, yeah, that's kind of up in there, right?
We're just showing the
location
of these CRIM and UWE.
Right, yeah, there they
So
are.
it's across Caldera. Not that far, about a mile and a half, roughly 2 miles. 2 miles.
A couple miles, yeah.
Right, and then the second one is right down here. This GPS station going across the rift, across Pu'o'o crater to Jacuzzi.
Right, yeah, perfect. Yeah, thanks for that. Yeah, so that's what we're measuring as spreading and the plots that Dan was just showing. And so here they are again. And so the point is, it's been slow and steady at the summit. We did have a kind of a little hiccup, a few months ago, but that seems to kind of been steadied out, and we basically are still on the same track as before, right? Looking at that lower one of those plots, we can scroll it up just a little bit. The Pu'o'o crater. Can we pull this up just a little bit right there? Thanks. So it's in the middle of the screen. Perfect.
All right.
And you guys can see that in October we have a big excursion, right? The plot actually rises quite a bit. at the Pu'u'o distance plot. And it was a fairly short, maybe a 2-week kind of event where it actually went pretty rapidly. And then since then, it's kind of resumed more or less the previous pace until recently, where there's a little bit more noise and it's hard to see what's going on here at the very, very end. Right? So this is a really interesting thing. You know, we haven't seen an absolutely convincing tilt signal, right? You know, earlier in the beginning of this process showing that something was actually coming in. But it could be that whatever changed over here in the area of Pu'u'o, because the ground definitely is moving. That's what this plot shows. You know, it doesn't tell us why the ground is moving. It tells us the ground is moving. And because the ground moved, perhaps the pathway has been fundamentally changed or, you know, temporarily changed or, you know, changed in some way that maybe the tilt isn't showing the signal down to Pu'u'o as it was from this one before.
Right.
USGS had something to say about this, right? About this event at Pu'u'o. And, you know, I can read you guys a little bit of what they say. Let me just get it over here, right? You know, kind of their overall take is that, you know, the Deep East Rift Zone is still slowly refilling. It's actually slowed refilling, going slower than before. But there was an inflationary event near Pu'u'o that occurred during the end of September through the first week of October. It says continuous stations near the cone, and we can pull up the map again perhaps, like OKIT, NPOC, and KAMO, which are those three kind of right in that area around Pu'u'o right there, along with KALR, which is a campaign station, experienced an acceleration of motion consistent with source inflation on a rift between Pu'u'o and Kupainaha. Now, Kupainaha is not very far. Kupainaha is right in there, yeah. So that's pretty much, yeah, it's pretty close. But that area right in between there, like, you know, that's a pretty small area in the grand scheme of things. You know, maybe a 1 or 2 mile region where the magma may have actually come into if magma was a source of that excursion in GPS, which is right now what the USGS appears to be favoring. However, you know, if it was magma that went in there, it did so without putting out extra gas, without any earthquakes at all. No seismicity was associated with this event, right? And at the same time, what the signals that we do see are of the south flank sliding, right? And the last time we saw a signal at Pu'u'o Crater, what was it?
The last time we saw a signal similar to this one, where it made that bump, was a little doohickey that was positioned right here, and one fell into the crater a little bit later. It was also given some weird readings, and then it meant its demise. The thing is what is this crater? Well, this cone, this giant cone. Well, we've known it's collapsed before. We know that it drained a year and a half ago. How much do you trust these stations when another station has already bit the dust? So that's always the question I have. It's how far is far enough?
Yeah.
We know that danger close is not good. The signal was bad. It got ruined. So where's the rings? What's the rings? What's the rings of trust on this thing? Right.
Yeah. So yeah, I mean, absolutely. There's other ways to look at this, but kind of overall, the pattern that we're in, maybe we can kind of step back and look at the big picture, right? Of like what might we expect in this kind of scenario, this kind of environment of magma refilling after that big collapse, right? There's all kinds of cracks in the ground, right? Here's while we're on here, I might as well talk about it. A picture of a basalt dike, right? This is on Oahu. This is a part of a paper that we're actually digging a new tunnel through for utility purposes on Oahu. And they're kind of documenting what they're having to drill through, right? So you can kind of see the kind of core in the middle between the two dashed lines. That's the actual, we call the basalt dike. That's like the blade of lava that shot in the middle of other basalt, other lava flows on the left and the right of it, right? That is kind of, when that word breccia is being used, BRECCIA, that's breccia, that means broken up rubble of basalt, basically, that's been turned into a rock right there, right? So the rock is getting fractured, the magma's coming in and filling in these gaps and making these sheets of lava right there, right? It's actually two of these. There's one in the middle, the big fat one. That's actually just a little crack, that big one.
No, the big
one, yeah. And then there's a little one, there's a smaller one. Yeah, exactly like that to the side, yeah. Over there, right? So.
And then there looks something over here. I don't even know what that is.
Yeah, it could be, yeah. I don't think I dialed up the picture of it.
Need a better resolution
for you guys, but what's common is that you have dikes occurring in swarms and systems, like in every volcano in the world. And these areas are, often a mile wide, or they can actually have quite a bit of width, right, breadth, where there can be a whole rift zone size area all cracked all the way through it, and magma can fill blade in after blade after blade after blade. So if you look at a map view of this later on, you actually would find that there's patterns of streaks across the line everywhere, right? Sometimes you can't walk more than 5 feet before coming across another one of these features.
Right.
Big picture, there's a lot of space down there within the rift zone because the south flank is moving away, and magma can come and fill those areas without having to crack the rock open and produce earthquakes, right? It can be doing it deep enough that there's not releasing any gas, and it can kind of be filling that, not even the deep rift zone, but the deeper part of the actual rift zone from the summit as the summit overpressurizes. And, it's basically, I thought of this as trying to fill up like an air mattress, right? Like, let's say you have family coming over, you got to fill up the spare mattress, and oh no, there's a little hole in it, and you try to keep filling it up, but someone lies down on it, puts a little pressure on it, suddenly all the air comes pressurized out of there, right? And kind of a burst comes out of there. So it could be that, the summit pressurized with, we know the summit, we assume the summit's still filling with magma. It seems to be doing that much more slowly than before, but we think it's still probably filling. And maybe it got to the point where some of it leaked down and went down the rift zone and got to this area of pool. So it's also possible that it actually was magma. And even if it was magma, it could be happening secondarily to the collapse, in fact, secondarily to the south flank movement, and kind of moving into the space the south flank is actually created. So that's possible too. This is a plot from professional paper 1806, one of the very first map, perhaps the very first map in the whole publication of the USGS, kind of trying to summarize the whole, dynamics in Kilauea, and kind of see what they've labeled as the south flank, and all those yellow arrows showing where the south flank actually moves, right? And then a couple areas where the flank, actually moves back and forth in two directions, kind of down an area where we are, and also kind of just south of the caldera, which are topics for a different day. But the big picture is, the whole south flank movement is...
And the south flank is still moving at an elevated rate following the magnitude 6.9 last year. That's one of the biggest takeaways, is that thing is still moving. The big section. Mostly, let me get a circle that's actually relevant. Yeah. About in there.
Yeah, maybe not even so far east.
Yeah, more in there.
Kind of in there. Yeah, exactly. That's second. Yeah.
Yeah, that's kind of the area that's been moving the most recently. It's not exact. Don't quote me on that one. That's just generalized area. Right. It's moving Middle East Rift, Upper East Rift, that area the most.
Right.
But yeah, this is just one way to wrap it up, kind of show you that big picture. I think we've gone through it all at this point. We're an hour in.
I can kind of sum up as far as dynamically, we're still in a point where we're not sure what's going on. Fundamentally, we're not sure like how good the connection is between the summit and the rift. Right, we're not sure if that connection is gonna strengthen or weaken from where it is now. Right, we're not sure how magma coming back into the summit may affect activity in a rift. It could be that we go through an era of magma filling in intrusions, filling in blade after blade after blade, filling in gaps and gaps in the rift zone for every few months. That could possibly happen. Or it could clog at any point, and that might allow it to actually back up to break out somewhere up the rift. And up the rift, we've been saying the summit's the most likely place, and it still is. But, it's in play because we have the signal all the way to Pu'o is somewhere all the way to Pu'o could also have something small happening. Right. And all this excludes all of Lower Puna, just so everyone is totally clear. None of this is going to happen anywhere where people are going to be near, right? So it's nothing that people need to worry about. I know we're all curious about it. We all want to know what happens next, because this is now a long saga in our lives, and the next chapter and the next chapter and the next chapter. We know that eventually this is going to lead to something else someday. We're not there yet. Right. And so we're not sure where we're going to land in this. Are we going to pressurize enough to pop out of the summit? Are we going to pressurize not enough that we're actually going to leak out somewhere in the Upper East Rift? Right? Not pressurize. Pressurize the summit enough, but have it leak out to the Upper East Rift and be able to rip there as well. Right? Or is the south flank going to keep pushing faster and faster than it was before? So it possibly can be taking more of this magma supply. We don't know where all the supply that existed for the last 20 years has gone yet. It could be going deeper down, not anywhere near the surface, and driving this faster mechanism on the south flank. And until the magma coming to the surface can catch up to the pushing of the south flank to the side,
Right.
can it really pressurize? So kind of to sum it all up, right, we have to have the south flank to stop moving, right? We have to have magma fill in that path between a summit and Pu'o'o and seal it so it can pressurize. Then we can pressurize the summit. Then we can pressurize the upper east rift again to actually have it erupt. So there's a whole lot of steps before anything can happen.
Right.
And so we're still looking for that. We're still looking at the whole problem as detectives and trying to figure out what might come next. But we're not anywhere near an eruption. Just kind of make that clear for everybody.
Yeah.
And that's kind of the summary of it. Really, is that a lot of interesting things are happening, but and even reasons for more vigilance, but nothing imminent about to go down.
Right. All right. Well, with that, I think we can wrap it up.
All right. So yeah, thanks guys.
That's right. Thank you. And stay
classy, Puna.
All right.